All right, guys, starting something new today, graphing simple rational functions. Your assignment today is going to be on a Google Doc on Google Classroom. Just wanted to work out graph. You can do it on your own paper if you want to, but I need you to turn it back in onto Google Classroom so I can check it out for you. Gonna spend 2 days doing this. Try to get the most you can today. We're gonna increase the difficulty a little bit tomorrow, so you really need to get today pretty well. And don't forget, we will have our first Google Meets on Wednesday during class time. So be ready for that. And I'll give you the exact time tomorrow, but you have the schedule. So whenever C period is, that's when we'll meet at the beginning of it. So make your plans now to be there. Okay, parent function. The parent function, the main function for rational functions, remember rational, when you see rational in algebra 2 or algebra, you're thinking fraction. And this is what the parent function is, 1 over x. Everything is based off of that graph. And if you look at the graph over here, the picture, you notice it'll have 2 asymptotes. The vertical asymptote is whatever makes your denominator 0. Your horizontal asymptote for right now is your x-axis. So if it's just a regular parent function, the vertical asymptote is the y-axis and the horizontal asymptote is the x-axis. But you know what's coming. You know we're going to shift those around. The graph are 2 curves. One's in the first quadrant, one's in the third quadrant. Those are called branches. The figure itself is called a hyperbola. That's the official name of it. That's called a conic section, which you'll study later in your math life. Any function of this form, a over x, remember that sure looks like inverse variation to me. The graph looks like that. Remember, direct variation is just a line. Inverse variation is a hyperbola. So no matter what number's on the top, the graph's going to look similar. The only difference is it may be a little steeper or flat, or it's a vertical stretch or shrink, depending on what that number on the top is. And the domain of range, we'll talk about here in a minute when we start graphing these things. But the domain of range is going to be all real numbers. It's going up and down forever, except it skips 0. It's also going left and right forever, except it skips 0. So that's going to be your domain of range, basically, is everything except for 0. Unless we move the asymptotes around, which we're going to. All right. Numbers added or subtracted from the inside the denominator will shift the asymptotes left or right, opposite of what you think. That should not be a surprise to you whatsoever in our class. The numbers added or subtracted outside the fraction will shift the graph up or down exactly like you think. That should not be a surprise to you either. If there's a number in the numerator, that number only represents the vertical stretch. Like if it's a big number like a 10, it's going to be really steep. If it's a small number like 2, it will be a lot flatter than the 10 would be. If the number is negative in your numerator, it's reflected across the x-axis. That should not be a surprise to you either. So instead of the curves being in the first quadrant and the third quadrant, they're going to be in the second quadrant and the fourth quadrant. They get reflected across the x-axis. Okay, translations. Here we go. Should not be shocked at all, especially what you just read. This is what most of them are going to look like. It's going to have a whole lot of stuff. All right. Now, whatever's on the bottom in your denominator, that's what's going to shift your graph left or right, opposite of what you think. So whatever number's down here is going to shift your asymptote from the y-axis, this one, to the right, opposite of what you think. The plus k on the outside, because it's outside, it's going to shift your asymptote up or down, depending if it's positive or negative. That should not be a surprise to you either. Okay, what I have left in this video are 3 examples. Make sure you understand them really well, and I think you'll be good to go. So let's look at them. First one's as easy as it can get. It's just y equals 6 over x. And by the way, if you look at that, that's inverse variation, which is why we did that first. Okay, there's absolutely nothing in your denominator with the x, which means the x-axis is the horizontal asymptote. There's also nothing added outside, which means the y-axis is your vertical asymptote. Those are my 2 asymptotes. And your curves. Now, here's what we're going to do today to get our points. I'm going to do it this time, but this will be the only time I do this. I'm actually going to plug numbers in. Like if I plug the 1 in for x, y would be 6. So 1, 6 is on the graph. And also if I plug 6 in for x, it'd be easy. 6 divided by 6 is 1. It's going to do this. So the graph's going to go through those 2 points and do that right there. Same deal. If I plug in a -1 for x, it gives me -6. So -1, -6 is on the graph. And if I plug in a -6 in my denominator, it gives me -1. So -6 gives me -1. So my curve does that. Oh, domain of range. My domain, let's write it this way. Let's put all x except x cannot equal 0 because it's going left and right except for 0. The range, I'm going to put all y except for y cannot equal 0 because it skips over the y-axis and skips over the x-axis. That's your domain of range. And your domain of range is going to be everything, all reals every time except for wherever your asymptotes are. That's how you can remember it. Wherever your asymptotes are, that's what's excluded in your domain of range. All right, this one has a bunch of stuff in it. First thing I see is it's got a +2 in my denominator. Remember, the denominator is shifts left right because it's inside the denominator. So that one's +2 is going to shift your asymptote left 2. There's my vertical. Right, the -1 out here does exactly what you think. It shifts your horizontal asymptote down 1. I'm missing right there. We try that again. It's going to be right at -1. So there's my vertical horizontal asymptote. Now, what we're going to do from here, instead of plugging points in, because it's going to get really messy, we're going to take the calculator and punch it in the calculator, punch this exact thing. Now, when you punch that in, I need you to punch in this. It should look like -4 divided by parentheses x plus 2, and then -1 to go to y. Sorry about that. Go to y equals. I can't do it. I'm trying. All right, go to y equals to punch that in. And what you're going to see, because the 4 is negative, which is not should be not a surprise either, it gets reflected across the x and y axis. So it's going to do this, and it's going to do that. And if you want a couple of exact points, when you put this in your y equals in your calculator, you can go to table, like I've shown you before, and find you some x and y values and plot you a couple of points on there. Domain. Your domain is going to be all x, except for x cannot equal. Now look, all the x's, remember x is going left and right. It skips everything. It's everything except for -2. And the range is going to be all y's except for y cannot equal -1. That's the y that it skips, is -1. Notice it skips -1 on the y-axis. It skips -2 on the x-axis. And that's what my domain and range were. And I'm going to show you one more. Hopefully that's enough. Okay, here's the last problem done on the calculator, and you're okay to do this. You're okay to graph it on the calculator, especially to check your answer, or at least find out where your curves go. But I still want you to tell me what the domain and the range is, and you draw your asymptote. Your calculator, if you notice the picture there, it does not draw the asymptotes for you. So on your graphs, even though you're using your free hand on your coordinate planes, please draw your asymptotes like I have been doing on those slides. But please use your calculator. Punch it in. Also, make sure when you punch it in, you use parentheses where you need to. Notice I use parentheses on my denominator because we're two terms. When that's the case, you got to use parentheses there, so be very careful to use parentheses. All right, the last one here says y equals 8 over x minus 5. This time, there's nothing in my denominator, so shift it left to right, which means my vertical asymptote is still here. Didn't get shifted left or right. There is a -5 outside, which shifts the graph down 5. Which means your horizontal asymptote is going to be at -5. That's a terrible asymptote. Let me try that one more time. -5. Boom, a little bit better. All right, now it's +8 on top, which means that my curve is going to be in my first quadrant, my third quadrant, know that for sure. And because there's just one number on the bottom, I'll just go ahead and plug a number in here. Let's plug in a 1, which will give me 8 over 1, which is 8, -5 is 3. So when I plugged in 1, I got 3, which is right there. If I were to plug in 8 on the bottom, 8 over 8 is 1, -5 is -4, so I plugged in 8 and got -4, which is right there, which means my curve is going to do this, just like that. All right, and if I do the same thing down here, if I plug in a -8, for example, it's going to give me -1 minus 5, which is -6, so I'll go -8, which is here, -6, which is there. And if I plug in -1, it gives me -8 minus 5, -13, which is way down off my screen, so curve's going to do this. And again, you can use your calculator to punch in what the curves are. What I need to see in your graph, though, which your calculator will not show you, are the asymptotes. I need to see your asymptotes. All right, so domain, all x except x cannot equal, look what I got skipped on the x-axis, the 0 did, so x cannot equal 0. It's what your domain is always your denominator. Your range is always the number that's outside. So y cannot equal 5, because if you look at your y-axis, it skips the y-axis right there at the 5. All right, guys. Again, your assignment is on Google Classroom. Get the Google Doc, work it out, make your graphs. You can freehand the graphs. I can't seem to get a graph to go through there. Maybe I can find some graph paper to put on there. I'll see what I can do. I'm at home, don't have access to a lot of things. I'll try to make it the best I can do for you, or you can get your own graph paper if you want to and do it on your graph paper. But you can freehand. I'm fine with you freehanding it. Just make sure you label or draw your asymptotes so I can see your asymptotes, and make sure you put your domain in range. And again, contact me as much as you need to. I'm enjoying helping you. And I'll talk to you a little bit later. Don't forget Google Meets on Wednesday during class time.